Electron beam machining or EBM. The EBM process works on basic principle of conversion of kinetic energy of electron into heat energy. When a high-speed electron impinges on a workpiece, they convert its kinetic energy into heat energy. This heat energy is used for a material removal by melting and a rapid vaporization. This process is generally carried out in vacuum. The EBM equipments are shown in this picture. The first important part is a cathode cartridge or electron beam gun. The basic function of this electron beam gun is to generate free electrons. These are made up of tungsten or tantalum, and the filaments of this tungsten or tantalum is heated to around 2500 degrees Celsius, and the heating leads to the thermoionic emission of electrons. The next part is a bias grid, which is an anode connected to negative bias to prevent the diverging of electrons generated by the cathode. Next to bias grid is positively biased anode. The combination of repelling force from a negatively charged cathode and attractive forces from the positively charged anode causes the free electrons to be accelerated and directed towards the workpiece. A magnetic lens is provided here to reduce the divergence of the electrons and to shape the beam. The electromagnetic coils focus the beam at a spot on the workpiece, and the deflecting coils prevent the beam from any deflection. When a high voltage is applied at the electron gun, it provides a high velocity electrons, and due to the pattern of electrostatic field produced by the grid cup, that is this region, the electrons are focused and made to flow in the form of a converging beam through the anode. Since the potential difference between the anode and cathode is very high, the electrons get accelerated through this anode. The magnetic lens focuses the high velocity electrons into a spot on the workpiece, and the deflection coils prevents any deflection of this beam. The workpiece is held in a vacuum chamber, and the work table is having CNC controls to locate exactly below the beam of electrons. The kinetic energy of electrons upon striking the workpiece changes to heat, which melts and vaporizes minute amounts of the material. The melt vaporization front gradually progressed like this, and finally the molten metal, if any, on the top of the front is expelled because of the vapor pressure created at the rear end. The entire EBM process occurs in a vacuum chamber, as explained earlier, because a collision between an electron and an air molecule causes the electrons to scatter and thus lose their energy and cutting ability. So the comparison of EBM in vacuum and in ambient condition is shown over here. We can clearly see that the beam is scattered because when it is hitting with the air molecules. The EBM process can be summarized like this. The mechanism of metal removal is melting and vaporization. The medium is vacuum. The tool, the beam of electrons moving at a very high speed. Maximum MRR ranges up to 10 mm³ per minute, and specific power consumption is comparatively higher at 450 watt per mm³ per minute. And critical parameters of EBM is accelerating voltage, beam diameter, work speed, melting temperature, etc. It is applicable to almost all materials. Then the shape application means are ranging from drilling of fine holes to cutting contours in sheets, cutting narrow slots, etc. And the limitations are grouped as very high specific energy consumption, necessity of vacuum, expensive machine, etc. Thank you for watching.